thank you for having me. It's nice to be back here with all of my Swiss Laravel friends. Tonight we're going to talk a little bit about technical debt. I know that this is a term that we kind of throw out a lot. It's probably something that a lot of you fight with your managers about. I know that I deal with a lot of clients who their primary interest is getting features shipped because features are what brings in the money. It's not, what version of PHP I'm running, what version of Laravel I'm running, or any of that. It's we need to move the needle. It's the feature that can move the needle. And if we can communicate how technical debt impacts our ability to move the needle, to create new features and to generate revenue, we can get managers, clients, whoever is making the decisions to buy in a little bit on putting some resources into getting it done. So, first, let's start to define technical debt. I know there are tons of papers on it, and everybody kind of has their own definition of what it is. I'll just kind of tell you how I think of it. First is the obvious. It's outdated code dependencies. It's, you've written something in PHP 7.4, and now we're about to release 8.5. It's still working, but it's a lot of work to get that updated, right? So that's obviously technical debt. Same thing with your packages and your framework. Keeping on top of all those upgrades, it takes a lot of work. It takes planning. It takes effort, and it's really easy to fall behind. For me, though, the biggest source of technical debt is lost expertise. Developers change jobs. You'll be working with a team, and the guy who wrote this big feature, he gets a better job, moves to another country, whatever. Now all of a sudden, the guy who owned that code, who really, really understood it, is gone. And he may not have written any documentation. The code might work really well, but it's readable. And so now, the people who are left behind struggle to understand what the code is. So just keeping it running is difficult, let alone improving it and modernizing it. In architecture, it doesn't quite fit anymore. Maybe you went to a conference, you saw a great talk on domain-driven design, you thought, this is definitely for me, and you walk way into it, and you built the first iteration of your app with this architecture, and now you have this new feature, and you're like, I don't know how to make it work within this architecture. I've made this thing so complex, I don't know how to add this simple feature. And so the decisions that you made really slow you down. So kind of the overarching definition that I have of technical debt is anything about your app is not an optimal way to meet your users' needs today. Because every day you're pushing code to production that works, it meets your needs today. But your needs, the business needs, your users' needs will change tomorrow. And so everything you do is technical debt the minute it hits production. So, where does it come from? Well, like I just said, pushing code production today to solve today's problems without knowing what the shape of the problem will be tomorrow is a big piece of it. I know we've all written features for a client, for our boss to solve a particular problem, and then because of the way business works, they decide that they need to change something just a little bit operationally. The operational staff, because they're human, they can adapt immediately to the new way of doing things. But software can only change if you change it. So when the business's needs change, it's your responsibility to go in and make that change. And you're almost always lagging behind the operational state. They're almost always finding a way to make what your software does kind of work for their new way of doing things, but you're behind. Another obvious place that technical debt comes from is, like I said before, you don't have the time to keep up with changes to the language, the framework, your dependencies. I mean, Laravel makes it kind of nice now. It's only upgrading major versions once a year. PHP, I think, is about the same thing. Most packages, if you're using kind of the well-known Laravel ecosystem packages, they kind of have their major releases planned around the language and framework releases. So it's not really that bad in our ecosystem if you're starting an app today to keep it up to date. It's sort of, you have to spend a little bit of time on it, but it's only once a year. It's not that bad. But there was a time when, I know, early in Laravel, the release was coming fast and furious, and they were big changes. hopefully you use Laravel Shift or something to make your life easier, but it was a real commitment to move from like a Laravel 5.2 to 5.3 awareness. I think when I moved to 11 to 12 on a bunch of apps, I only had to change code in 2 of them maybe. I mean, there were so few minuscule breaking changes. So that part is getting better. And then, like I said before, losing knowledge required to confidently change what's already in place. Some of this obviously is, staff change. Your former coworkers left, they really knew how to do this thing, you really don't. The lack of documentation, but really lack of tests. Because if you create and maintain a good, robust test suite, that gives you the knowledge of how things work. You can read the test and understand from the test how the application is expected to work. Tests really are the best documentation you can write. And I think most of us don't have enough. Honestly, I do this for a living, have for a long time at a high level, and I don't think I have a single app where I feel like my test suite is bad. It's always just a little bit light. And now, a huge new addition to our source of technical debt is vibe coding. And man, can you rack up technical debt fast. This credit card, you can swipe it many times you want to. You can have a 200,000 line app in a couple of days and have no idea how any of it works. Push to production, and all of a sudden, you need to call someone to maintain this thing. Well, that could be trouble. So how does it actually, why does it matter? Like, why does technical debt matter? If you're a developer, you understand why it matters, because you're frustrated. You have all of these outdated dependencies, you want to use new language features, you're hearing about it from above that, page loads are too slow, or jobs are taking too long to run, and you recognize that if I could just get off PHP 7.4 and onto PHP 8.4, the performance gains just in changing the language would be huge. But that takes a lot of work. So let's say your boss tells you, I have this new project. You're not going to see a line of code on it. It's a brand new idea. You're going to spend some time. You're going to write the spec. You're going to architect this thing really well. You're going to build a castle. You have all the instructions, every single piece in place. You can make the perfect castle. And so you build it. It's a great castle. Absolutely wonderful, perfectly done to spec. Boss comes back the next day, we need to add a rooftop bar. So we go to our castle and take a look, and that's going to be complicated. Because again, we built the castle to spec based on the needs that were stated in the moment, not understanding that down the road, you might have to add that rooftop bar. So that's kind of a visualization of technical debt. You are put in a position where you have to add a new feature that the underlying architecture of the application is woefully unprepared for, and your boss is going to take that as an excuse. You have to figure out how to get it done. So the best way to do this is to start paying down technical debt. Start future-proofing your application. Start locking in that knowledge so it doesn't walk out the door when a coworker leaves, or I'll be honest, there is a lot of knowledge happens even for me with applications that I'm still responsible for that I wrote 10 years ago. And I go back into them, and I'm like, who the hell wrote this? What does any of this mean? I wrote it in Laravel, but I don't understand any of it because it's just been so long. You lose that context, you walk away, so you yourself can lose that knowledge. So you need to start paying down technical debt. And that's unfortunate. So I went to Denmark last week for Laravel Live UK. And while I was there, my wife sent me a text message and said that our toddler had come home with a really nasty stomach bug. And I considered briefly staying in Denmark in order to save myself. But I did the brave husband thing, and I came home to be supportive and take care of my family. And so I spent the last couple of days with the same stomach bug he had. So my slides have ended, unfortunately, prematurely. So, I know, 6 years, dog at Denmark. But let's talk about technical debt a little bit and how we can start addressing it. The title of my talk is, We Can't Manage What We Don't Measure. And so what I want to talk about a little bit tonight is how we can measure the technical debt that our app is carrying. And there are some very obvious ways that we can measure technical debt, right? We can compare our version of PHP with the current version of PHP. We can see, is our PHP version end of life, or is it still supported? If it's still supported, maybe we have a little bit of time. So if it's end of life, we really probably should use something. We can do the same thing with our framework. We can do the same thing with our composer dependencies. So it's pretty easy to measure the amount of technical debt we have with regard to out-of-date language, framework, dependencies. And we know to the extent that those things are out of date, our application code will also be out of date because it was written to the standard of the language and framework at the time it was written. So that's a pretty good metric, right? How far behind the current version of everything are we? Other metrics are dead code. Dead code is basically code that lives in your app but is never executed. This happens all the time. I write a ton of dead code, and quite often I have this big class that does this big thing. I can refactor this class, but it's easier for me just to start over, give it a similar name, and do basically all the same stuff. So I'm basically rewriting a feature. It's not rewriting a lot, I'm rewriting a feature. It stays in the app, but I never actually get around to deleting the old one. But I think if I leave this other one here, if the new one I wrote falls apart when I deploy it, I can always revert back to the old one. And it's a thing that we do just to save ourselves some time and give ourselves a little bit of assurance. We don't go and think about it ourselves. I opened up an application that I wrote 13 years ago, and there was a bug. And I did a full text search to try to identify where this bug happened. And the particular string that I was looking for existed in like 73 files. So I'm like, how many different times did I try to solve the same problem and never actually delete the old solution? And it's bad habits that I was in, but I think it's, to some extent, we all do stuff like that. So taking the time to identify the code in your project that never executes, that doesn't exist within any possible execution path, and getting it out of there, makes it easier to fully visualize your app and really see where the problem lies when you see something in your error logs, or when your boss comes to you and says that you need to augment this feature. In this case, I was asked to slightly augment a feature in this 13-year-old app, and I couldn't tell which version of the feature I should augment because it took me a while to figure out which one was actually in a valid execution. I did delete the other ones, so I learned my lesson there. Some other things that are not necessarily so easy to measure without some tooling or without spreadsheets and things like that are kind of your Git habits. How many stale branches do you have that are sitting open that have not been touched in months? Things you started trying to do and failed, or hit a blocker, or got yanked off that project onto another one, never got back to. Sort of this, like, it's not in your production code, but it's just sort of this dangling work that probably will never make it into production. How often does that happen? It's going to happen all this sometimes, but if you have dozens and dozens of these branches that only go so far and never get merged in, that's probably an indication that you have a high technical debt load on your application because you're not actually able to bring new work to completion. How long does it take from the moment you open a PR until the time that it's reviewed and merged? If you're in the sort of organization that does that. I mean, some people work their own work, some people work for a domain, so you can't always measure things this way. But if you work in a team where you have a pull request workflow, do pull requests sit open for days or weeks or months before they get reviewed and merged or closed? Or does that happen quickly? If it's taking a really long time, that's an indication that maybe you have more technical debt than you should. The other thing that you could do is you could just go back and read through your commit messages and just analyze them for sentiment. If you have an application with a high level of technical debt, you're probably frustrated. And that frustration very likely will show up in commit messages, either in subtle ways like fixing this again, or less subtle ways, which I can't say on stage. But if you read through my commit history, you'll see plenty of it. So, that's just sort of another indication. And there's just the basic code quality stuff. There's all kinds of great tooling out there. Second matter complexity. You can run things like PHP Mess Detector. I think Nuno has a package that PHP Insights, I think is what this is called. They all kind of look at applications from a different standpoint and give you measurements of code complexity, likelihood that this piece of code is dead, and PHP stand, which is kind of the cornerstone. PHP stand and Rack are kind of the cornerstone of everything that I do when I'm dealing with technical debt. PHP stand, static analysis, is really good at static analysis. It's really good at being able to read your entire application and understand the logic flow. Especially when you get up to level 4, level 5, and above. If you can get your application passing PHP stand at level 4, you can start doing some automations using Rector and other automated refactoring tools, and have a relatively high level of confidence that those automated refactoring tools are not going to break anything. So that's something that, it's a great tool for measuring the health of your app and giving you confidence that you can actually start to pay off technical debt. So we have a couple of clients, one of which has dozens and dozens of applications. And so we spend a lot of time dealing with and finding ways to pay down their technical debt. And we've been using a lot of this command line tooling. And coming up with ways to sort of operationalize the measurement of all these different things we talked about. The number of open branches, the time that PRC get merged in, the percent of the code that's dead code, and that sort of thing, in an effort to try to score and then track across time the health of the app from a technical standpoint. And I know I promised a little bit of a verbs talk. So I was originally, when I said I would talk here, my original plan had been to make this kind of a real verbs event sourcing talk. I know we've had several event sourcing talks here in the past. We had not had one on Funk's verbs package, which is kind of their take on event sourcing. In building out this tooling that we're using for our clients, we're using verbs. When we run an analysis, we fire an event. I don't know, maybe before I get into this, how familiar is everybody with event sourcing? Okay, so a few people with event sourcing. Basically, event sourcing, I guess in the simplest terms, I'm going to let Bobby come back up and explain it, because I'm sure he's done more real event sourcing than I have. For me, event sourcing is, the way I use it, you're familiar with the action pattern, I assume. I use event sourcing like the action pattern, and I fire events the way that I would use actions. And when you fire an event, all of the data that you would normally pass to an action gets stored in that event. And then from there you manipulate a state, optionally, or you make changes in eloquent or whatever you want to do from there. But the difference between a regular action in Laravel and an event is simply that the event is actually stored to the database along with all the data that comes in with it. So if later on you decide, oh, you know what I did with that event wasn't quite right, my business logic was a little bit off, you can go back and you can rerun all of the events and it fixes your data. That's not my use case here. My use case really is, I mean, it's kind of my use case, but my use case really is I want to be able to track technical debt over time. So what I'm doing is when I run the event that detects the PHP version, the framework version, the number of lines of code, the percent of dead code, all of those things, I fire an event and it creates a state, a snapshot in the moment in time. And then when I run that same stuff a month later, it stores a separate record, and I can create like an overall score. If I change my scoring algorithm, I can rerun all of those things, and it updates the scores across time. So I don't lose that relative progress if the score was 500 the first time I ran it, but I changed the scoring algorithm, and so now that would have been higher, I can just rerun all the events, my scores are adjusted. To make this kind of make sense, this is something we're about to release to the community. It's a commercial product. If you have a high-paying application, you want us to help you pay down your technical debt, you can do that through here. But what I want to show you today is the kind of the work-in-progress free thing that I'm hoping all of you will get a chance to use, and maybe it will help you to identify and pay down your technical debt. You connect your GitHub account to it. It's going to take a minute or so to get on the repositories because I authorize too many organizations on here. I'll show you real quick. This is what a state looks like in Rails. So your events will manipulate a state. They'll basically set these properties on a state, and these just get serialized and added to your database. So there's the analysis ID. This is basically just the identifier. And then all this stuff down here, PHP version is PHP end of life, framework name, framework version. This is all just captured in the moment that the event is run. And so I know that as of this day, at this moment in time, all of this stuff in here is true. When I run the same thing a month later, a new record, a new state is created, but I can compare all these states across time and create a report. Going back here, this is probably. You know what? It's because I'm not connected to the internet. I'm using the free airport Wi-Fi. Are you kidding me? So anyway, anyone have a good joke? I can go back in here. I just need to show you that. App events. Let's see how this is. Framework elements. All right. So basically, I just take in the analysis ID. Like these things in the constructor are. They're basically what allow me to connect this particular event to the repository that I'm analyzing. And and I pass in the name, the version, and whether or not it's end of life. So I'm actually doing the checking outside of the event and passing the data in here, and it just saves it to the state. Again, if I had more than 30 minutes and I had verbs for 1.0, I would actually do a proper verbs talk because some of this stuff is really cool. What you can do, but let's go back to what I actually can show you. Okay, so the lesson here is don't use airport Wi-Fi. All right. Without making a demo of this, it's fine. Basically, what we're driving at, and the report that I would have been able to show you is about halfway there. It shows your PHP version, whether it's end of life or current. It shows your framework version. It shows the number of lines of code you ran. It shows how much of that is dead code. It gives some code quality scores using, I think, PHP Insights and PHP Mess Detector. Just going to give you a general idea of how the tooling that is common in the industry will look at your app. There's some more in-depth stuff that runs longer, so it doesn't show up on the report immediately. You can get an email later telling you kind of like how many things are failing at PHP level 0, how many at 1, how many at 2, how many at 3, how many at 4. It's going to show you how much work you would have to do to get your app up to the PHP standard, where you need to start doing real automation in fixing a technical debt, and that sort of thing. And I swear, I'm to read all of this. So if you want to try that, obviously not on airport Wi-Fi, and so far everything I'm going to show you is just working on my local machine. I haven't actually deployed it yet. I did have big plans before I came home this time. It'll be at phpstore.com. And like I said, the analysis of your technical debt is free, always will be, and we'll offer free monitoring, so you can get the same report run every single month. It'll come with a few tips on kind of how we would approach paying down your technical debt. Say kind of like a prioritized list. Like the first thing you should do is get smoke tests on all of your runs. It's really important to have at least your important stuff under test before you start refactoring. Otherwise, you break something, your attempt to make things better just make things worse. So smoke test on all your routes, PHP standard level 4, and then start adding types if you're in a PHP level that allows for that. So we kind of knowing what version of PHP you're on, we can give you a list of kind of checklist of things that you can do to start paying down some of that debt, and recommend the tooling can help make that happen. And so I'm hoping that all of you will get a chance to try it out and use it, and that it can be beneficial to you, because until we started really systematizing and measuring how technical debt was impacting our own projects, our clients' projects, it really was a really frustrating experience to have a stakeholder, a decision maker, coming in and asking, why are these page loads so long? Why is it taking so long for us to get this feature done? Why are we paying so much for this server? We only get 200 users a day. Why is it costing us $300 a month for servers? The sort of thing that happens when you have a very out-of-date app that needs a lot of work to get to the level of performance that PHP is capable of today. So, does anyone have any questions? Does anyone have the Wi-Fi password?
If there are no questions, then pick up also heads and